What would be the equilibrium concentration of H plus and hydroxide if you start with a mixture where H plus is 0.1 and OH is 0.2? Okay, so initially you have 0.1 for H plus and 0.200 moles per liter for hydroxide. And the KEQ for this reaction is 1 times 10 to the negative 14. Okay, what's our Q? Products over reactants. So it's going to be H plus over times hydroxide over activity of a liquid, 1. Right? So, and the exponents would be, coefficient here is 1, coefficient is 1, so that's 1 and 1 there. So H plus is 0.1, hydroxide is 0.20. What's our Q? 0.1 times 0.2 is 0.0200. Is that less than or greater than KEQ? Compare that to 1 times 10 to the negative 14. That's greater than KEQ. So which way will the reaction go? Left or right? Left, right? KEQ. Q is greater than KEQ. Reaction goes to the left. So the changes would be minus X plus X, right? And really don't care about the water anymore because that's just going to be a 1 in terms of activities, right? So what would be the values at equilibrium then? This is going to be 0.100 minus X for H plus and 0.200 minus X for hydroxide. Now, can I make a simplification here? What is this KEQ? Is this considered a very big number, a very small number, or somewhere in between? A very small number. So it favors what? At equilibrium, it strongly favors reactants, right? So one of these two is going to get used up, right? Which one do you think is going to get used up? The 0.1. So this is going to be, and this is going to end up being essentially 0, right? Trace amounts. And what happens to 0.2? You lose 0.1 out of that, right? So your X is going to be equal to 0.1. So this is going to be 0.100. So what would I do to get my concentration, my actual concentration of H plus? Okay, so you need, now at this point Q is 0, right? Numerator is 0 because of this. If you put 0, so it's actually going to shift a little bit back to the right. So we're going to shift this back a little bit to the right. So I'm going to add plus y and plus y over here. So our KEQ then, 1.00 times 10 to the negative 14 equals y times 0.100 plus y. All right. What simplifying assumption can I make? I know that this y is a trace amount, so that's negligible compared to 0.1. How do I solve for y now? I can just say y equals 1.00 times 10 to the negative 14 over 0.100, and where y is going to be equal to, what would this be? 1.00 times 10 to the negative 13. Okay? And so y is my H plus concentration. And what's my hydroxide concentration? Is 0.100 plus y. So that is just going to be 0.100. Okay, let's verify that H plus times hydroxide is equal to KEQ. This is 10 to the negative 13 times 0.100. Okay, and you can see that in fact it is 1.00 times 10 to the negative 14. So our assumptions are correct. Okay, so that's how you solve. So solve problems where the KEQ is very large or very small. Anytime you see KEQs that are very large and very small, you should be thankful because that makes your problem easy. Okay? So this would be a good place to stop.